Okay, instead of having you guys go through these two questions on your own, we're going to try to go through these two together and see what we got. This is on systems. Systems are uh, excuse me, two or more equations, and we have 4x plus 3y is 20 and 2x plus y is 7. It says if xy is AB is a solution to the system of the equations, what is the value of B? Okay? Do you remember how you solve a system? Do you remember how you solve a system? Substitution is an option. Elimination is an option. So let's just kind of think about what you guys are thinking through. What could you multiply the bottom through by in order to make something go away? You can multiply it through by a -2, or since you said -2, let's multiply through by -2, okay? So we have 4x plus 3y is equal to 20, and then we have -4x minus 2y is equal to -14. So multiply everything through. Now, Jack brought up a good point. He said he really likes substitution. If you want to take this problem, do substitution, you sure can. When we add these together, what goes away? The x's. And then you have 3y and -2y make y, and 20 and -14 make 6. Now, it says, what is the value of b? Is b the x value or the y value? So 6 is the correct answer. Look at the next one. Next question is different. It says, how many solutions are there? None, one, two, or more than two? And if you went to solve this, what could you multiply through by here? A -3. So we have 6x plus 3y is equal to 5. And then we have -6x minus 3y is equal to -6. What happens when you add those together? The x's and y's are both gone. So what is left on the left-hand side? What's the only thing that remains? 0 equals -1. What does that mean? There are no solutions. None. Looks like I forgot to put a couple graphs here. There are 3 types of linear systems. So we looked at the algebra. Here's a graphical representation of what we're talking about. This is the most common situation that we have. We have 2 lines that cross once. We say that's one solution. That is the most common scenario that we have. The second set, anybody think of a different set of lines I could draw? Yeah, and if they were no solution, what would they look like? And if they're not touching, they would be parallel. So you could have one line like this. You could have another line running like that. And in this situation, because they're parallel, there is no solution. So it turns out that the ones above here, this one right here, it turns out that that's a situation where you would have no solution, that the lines would be parallel. Anybody think of what the third option would be? Infinite. Yeah, they're the same lines. So you would have a line like this, and then you would have another one that sits right on top of that bad boy. So you've seen systems before. These are the 3 types of situations you can come up with. So there's really 3 methods that we use. The number one is really the least used, and that's solving by graphing. So you can see this first one here, y is equal to x minus 2. As we graph that, if we just go down 2, and then up 1 over 1, sounds like they're rocking out next door, huh? I know a lot of people for the next one that they would they put that in slope-intercept form. So 2y is equal to negative x plus 6. We divide by 2. Y is negative 1/2 x plus 3. So I plot 3, down 1 over 2, down 1 over 2. Doesn't look like they intersected just a perfect spot, do they? So that's the trouble with graphing, is sometimes you're estimating the point of intersection. And I would estimate this to be about 3.5 and about 1.5. Would you say that's a decent estimation? You know what I get tired of? There are things with math. I get tired of it sometimes. I always get tired of putting stuff in slope-intercept form. Like, wouldn't you like to just graph these and not put them in slope-intercept form? Let's do it. Let's look at the x and y intercepts. Cover up the y. What would x be? Close. Negative 2. 2 times negative 2 is negative 4. So that means the x-intercept for the first one is negative 2. Let's find the y-intercept. Cover up the 2 x's. Then you have y is 4. Hey, that was quick. Do the same thing for the next one. Cover up the x. What's the y? 7. Cover up the y. What's the x? What would you estimate to be the point of intersection? That's solving by graphing. Jack, what was your option for solving? What did you say? Substitution. Substitution's another option. You can see right here we have x equals 2y minus 10, or y equals 5 plus 1/2 x. If you have an x equals or a y equals, that's where you can substitute. So I would take what x equals, and what do I do with it? Plug it into the x in the other equation. I get y equals 5 plus 1/2 times, and make sure you put parentheses around it so you distribute through. 2y minus 10. So y equals 5 plus, what does this come out to be here? 1y minus 5. What's going on? Huh. Y equals y. Infinite solutions. Exactly. There's a number of ways in which you can make it turn out. 0 equals 0 as well. If you get the same thing on both sides, then it's infinite. Try the next one on your own. Try the next one on your own. Use substitution here. See what you get there. Try that. Take that 3x plus 2 and drop it in for y here. See if you can. All right, let's see what we get. 3x minus 2 times 3x plus 2 is equal to negative 1. You distribute the negative 2, 3x minus 6x minus 4 equals negative 1. Solve for my x's. Negative 3x minus 4 equals negative 1. Add the 4. Negative 3x is equal to 3. Divide by negative 3, so x is negative 1. Did you get negative 1 for x? So what the heck do we do for y? How'd you know to put in the top one, not the bottom one? All right, so the top one already says y equals. The fact is you could use the top or the bottom. Either one works. But since the top says y equals, it's nice and easy to plug it into here. 3 times negative 1 is negative 3, plus 2 is negative 1. Jack's on fire today. Way to go. Mono all done? Jack? Mono, gone? You're good? You should take tomorrow off. All right. Elimination. If I add these together right now, nothing's going to cancel. What would I have to do in order to make the x's or the y's cancel? Times by -1. So Zelly sees that he wants the y's to go away. They're the same. If he multiplies through by -1, look at what he gets. He gets 5x minus 4y is 0. If he multiplies through by the -1, now he's got -8x plus 4y is equal to -12. Did you do substitution? Oh, so you multiplied by like a -8 and +5? Okay. Yeah, here you just, let's get rid of the y's. You can see that when you add those together, the y's go away. 5x and -8x make -3x, and 0 and -12 make -12. So x is 4. If x is 4, how do I find y? Does it matter which one I plug it into? It doesn't. So we plug it here, we get 20 minus 4y is equal to 0. Or -4y equals -20. So y is 5. So what do you do for the next one? First, you just make a decision. Leslie, do you want the x's to go away or the y's? You can choose whatever you want. She wants the y's to go away. So if I'm going to choose the y's to go away, then I got to make the -3 and the +2 change. Okay? So what number would you like to make them into? 6 is a good shot. One's got to be positive, one's got to be negative. So let's multiply the top through by 2, and we get 8x minus 6y is 22. So what do you multiply the bottom by? -3. And we get -15x plus 6y is -36. Add those together. -7x equals -14. So x is what? 2. Plug that 2 back in. 8 minus 3y is 11. Subtract 8. -3y is equal to 3. Or y is -1. Do you realize that what we've covered within these about 15 minutes, that when your teachers taught you this in algebra, it was an entire unit. Like you spent 2 days on graphing, 2 days on substitution, 4 days on elimination. Okay, so hopefully, I know it's a quick review, but that's part of what this class is, a nice brief overview of what we had. We're not going to solve all these, we just want to talk about setting them up. Would you use elimination or substitution to solve this one? Why substitution? Because you already have y equals. So you would take this and dump it in for y. How about the next one? You can really use either. I would probably subtract the 2x over and use elimination. Some people might divide through by 3 and use substitution. It's up to you. I would choose either. How about the last one? Would you use elimination or substitution? Elimination. What would you multiply through by? A -2 on the bottom. So you have 4x and -4x. That's a good thought. Yep. Good. Good. You're ready for your assignment.